Yeah, I love repairing things and pushing my possessions to the limits of their lifespan. Unfortunately, many of the objects we buy seem predestined to fail prematurely. So when I get my hands on an actual, good, solid, well-designed tool, I try to keep it in working condition as long as possible. And here's an example. The Philips Multi-Groom, well, Groomer. This is an old version of the 5000 model, and with a bit of maintenance, it works really well. For me, at least, but my needs are fairly basic. The original kit came with an assortment of attachments, different grooming heads, a nose and ear hair trimmer. Actually, I think it's more of a puller than a trimmer. A micro screen type of razor, and a small brush. But mostly I use this head and this blade guard. The only maintenance I've ever done on this is opening the trimmer with a 2mm hex key, cleaning out all those stray hairs, and giving it a shot of lube. And I found that dry lube for bikes actually works pretty well. And it's rechargeable, but the battery has pretty much lost its will to live. So let's take a look inside. It's held together by some pretty tenacious clips, so I'll try to hide the fact that I've opened it up already a couple of days ago. And I'll act all surprised and try to mask the nasty nicks I made while prying this open with some screwdrivers. As I'm doing again, there's something I just can't figure out where the clips latch on. And oh my, some clips have been snapped off the inner casing. That's the one that keeps it waterproof if you want to use this in the shower to, shave. So let's putz around and check the voltage and stuff. Voltage in with that wall wart charger with the really thin crinkly wire says anywhere between 10 and 17 or 20 volts. Anyway, but this right now we're at 16.3 volts. So does it keep a charge after all these years? Well, I can tell you it doesn't. This right here, it's a fairly common 3.7 volt, 680 milliamp hour lithium ion battery. And it has these leads already spot welded to both ends. So first we'll remove the old battery. Standard practice is to tin your tip. And just a bit of double-sided tape to hold the battery in place. One of the leads snapped off. It's held there with the three very, very weak spot welds, tiny little things, and it just fell right off. So we'll solder that back on. In this case, I'm sanding down the terminal of the battery and applying some flux. But it seems that lithium-ion rechargeable batteries are sensitive to heat and can be damaged if overheated. The positive end of the battery has a small area, so there's less heat dissipation than the negative end, which is pretty much the entire metal casing of the battery. I'm soldering onto that big negative end, and the rule is hot and fast. Get some flux to flow in it here, and you can let it set. And then solder your lead. Set this back into the board. And solder the leads back in place. I'm using some isopropyl alcohol to clean off the extra flux that I put on there, and I put a lot of flux. So everything's set. I'll plug this in, check the voltage. It is charging slowly. I don't know, maybe leave it, I don't mind leaving it all night or giving it a couple of, I'll leave it all night, and we'll see what we've got tomorrow morning. I'm taping up the ends of the old battery and dumping it into my dead batteries box. My daughter asked me what this logo was. Well, there was a legendary San Francisco punk band back in the late 70s to mid 80s called the Dead Kennedys. This is based on their logo. So not Dead Kennedys, it's Dead Batteries. Well, this works perfectly, so fix your stuff, friends. And thanks for watching.